Okay. Um, I know I'm probably one of those teachers where I say everything that we learn in math is important, and sometimes when I say that I'm lying. Today I'm not lying. Today, the chain rule, I would say that this is the most important thing for you to learn to be able to do your final exam. Okay, this thing today. We're going to learn how to find derivatives using the chain rule. So let me give you an example, okay? All right. So before we get to the worksheet, and the nice thing is it's not super difficult, okay? So do you remember last year when we did function operations like f plus g and f minus g and f times g and f divided by g? We had another one in there. Do you remember the other function operation we talked about? F of g, the composition, right? So I'll give you an example. Say y is equal to sine of 3x. Well, if f of x was equal to sine of x and g of x was equal to 3x, then isn't this f composed of g? We take that 3x and what do we do with it? We plug it in right there, right? And so when we have function composition and we want to take derivatives, well, things change. For example, if I asked you 2x to the third power plus 1 to the 100th power, and you wanted to take that derivative, well, you would have to multiply this out 100 times, wouldn't you? You would, okay? But I'm going to show you today that the derivative is simply 600x squared times 2x cubed plus 1 to the 99th power, okay? And it's not going to be any big deal. Here's why it's called the chain rule. Let's consider y is equal to sine of 3x, okay? We have a couple things happening here. You guys ever seen like some sprockets, some pulleys? You know, you got a chain and it's turning things at different rates. Yeah, you're a son. So then we got this guy right here. All right. So all right, we'll try again. Getting too much grief here. We'll just go for circles. Okay. Uh, so here's what happens. Okay. Suppose we have a belt that goes around these two pulleys. Okay. All right. As this belt moves, are these going to move at the very same rate? Which one will make a revolution faster than the other? The smaller one will make a revolution faster than the other, won't it? Okay. And so what we say is that this is like the inside function. This is like the outside function. Now, at what is the rate of 3x? What's the derivative of 3x? 3. What's the derivative of sine? It's positive cosine. Okay? And so the derivative using the chain rule is the derivative of the inside times the derivative of the outside with the inside left alone. And that's how it works out. Okay? And it's really cool. If we organize our work using the graphic organizer I've given you, it can work out pretty well. And here's the rule. It says given composition function f of u of x, the derivative is the derivative of the inside, which is u prime, okay, the derivative of the inside, times the derivative of the outside. But we leave the inside left alone. So when you look at these, this graphic organizer is going to help us kind of put our work together. U of x is going to be referred to the inside function. What is the inside portion here? 2x plus 3. Now the one change I'm going to make is instead of using a variable of x here, I'm going to use a variable of u. The outside function would be u to the 4th power. So those are the things that we compose together in order to get 2x plus 3 to the fourth power. Okay? What's the derivative of 2x plus 3? 2. What's the derivative of u to the fourth? 4u to the third. Now, this arrow here reminds me that I take the original, the 2x plus 3, and I plug it back in for u. Okay? So the derivative ends up being 2 times this piece. 4, and what is u? Can I multiply the 2 and the 4? So therefore, f prime of x ends up being 8 times 2x plus 3 cubed. Look at the original part here. Okay? Derivative of the inside times the derivative of the outside with the inside left alone. You see that? Okay. Let's practice again. What's the inside here? Good. What's the outside? What is the derivative of u to the fifth? What's the derivative of 1 minus 2x minus x squared? Good. Negative 2 minus 2x. I take this, and I put it back in here, and I multiply by that. Now, I'm going to be careful to show you the mistakes that people make on the test as they write this answer. I'm going to write negative 2 minus 2x times 5, 1 minus 2x minus x squared, all to the fourth power. What's wrong with that answer? Okay. I could simplify it. I could multiply that 5. Do I multiply the 5 through here? I can't multiply. Why can't I multiply through here? Because I have to take it to the fourth power first, right? Order of operations says take it to the fourth power first, then multiply. So I can't multiply 5 through, but can I multiply 5 through here? Yeah, and furthermore, this is saying that it's just negative 2x times 5. It's this whole thing, right? So you need to include those parentheses. And as we multiply, we have negative 10 minus 10x times 1 minus 2x minus x squared, all to the fourth power. So when you're saying it's this entire piece times that, we need to make sure we include parentheses. I will take at least a half a point off if you don't do that. Okay? All right, the next one, number 3. What rule did we use in the past for a problem like number 3? The quotient. I say, I don't like the quotient rule. I'm going to use the chain rule. 3 times 4x minus 2 to the negative 1 power. See how I rewrote it? What's the inside? What's the outside? What's the derivative of 3u to the negative 1? Negative 3u to the, so negative 3 over u squared, right? Pause. What is the quotient rule? F prime g over what? Do you see how this comes up with the squared in the denominator? Just like the quotient rule did? Isn't that nice? There it is. What's the derivative of 4x minus 2? 4. Multiply them together and I get f prime of x is negative 12 over good. If you did the quotient rule, you come up with the same thing. Go ahead and try number 4 on your own. I would encourage you to rewrite it just like I did. Try number 4 on your own. Yes, Michael. So I multiply these together. And 4 over 1 times negative 3 over u squared will give me a negative 12 over u squared, since u is 4x minus 2. So that was not better? Good. Ten over x minus 1 to the 6th. Now, let's pause here. If you would have used the quotient rule, you would not have gotten x minus 1 to the 6th in the denominator. You would have gotten x minus 1 to the 10th, right? And you would have had some other stuff up top that you would have had to then simplify with. You see what I'm saying? So again, the chain rule can be very advantageous because you may even reduce steps in the process. Question, Carter. So the inside is x minus 1. The outside is negative 2u to the negative 5th. Derivative of negative 2u to the negative 5th is 10u to the negative 6th. So then this is 1. I multiply them together. Better? Okay. Hey, let's do some trig. What's the inside here? 3x squared. What's the outside? Cosecant of u. What's the derivative of 3x squared? What's the derivative of cosecant of u? Yep, you're going to have to memorize those for the test. You need to know those. Let's multiply. We get a f prime of x is negative 6x cosecant of 3x squared cotangent of 3x squared. Could you imagine trying to find that derivative without having the chain rule? What's the inside? What's the outside? What's the derivative sign of u? Not cos, not cos. Derivative tangent? Yes. Secant squared of x. So I multiply them. Secant squared of x times cosine. Is it cosine times tangent or is it cosine of tangent? Which is it? It's cosine of u. This is not times, it's cosine of. So it's cosine of tangent of x. It's very important that you do not write this. This will be marked incorrect on the test. Cosine of x times tangent of x. People will write that. That is incorrect. It's the cosine of tangent, not the cosine times tangent. See that? Okay, when you get back, we're going to do 2 examples that are not on your sheet, and then you'll be able to have time to work. Some of you will finish this assignment before the hour is over. Go get some brain food. Come on back smarter. Oh, we got 1 minute yet. This derivative, that means the same thing. Well, if you wrote, okay, I understand what you're saying, Michael. This is why I'm bringing it up, because there's some confusion about it. If I wrote this, how do I know the difference between this and that? Like, because this looks like it's sine of x cubed. You're cubing the x and then taking the sine of it. this is saying you're taking the sine of x and then you're cubing it. That's why they write it the way that they do. So if I were to look at this and we were to write out the derivative, I use the chain rule. What's the inside? Sine of x. What's the outside? U to the third. Derivative u to the third. Derivative sine. So are you squaring sine or are you squaring 3? You're squaring sine. So it's 3 sine squared of x times cosine of x. That's your derivative. So if you see that, you have to rewrite it. Now, one more. You won't have to do this today, but I want you to see this. Isn't this the same thing as negative 4 times cosine of 5x, that quantity squared? So what's the inside? The inside is cosine of 5x. What's the outside? What's the derivative of negative 4u squared? How do I find the derivative of cosine of 5x? What? Yeah, you got to do the chain rule again. What's the inside? What's the outside? What's the derivative of 5x, or cosine of u? What's the derivative of 5x? What's the derivative of cosine of u? Negative sine of u. So the derivative here is negative 5 sine of 5x. So now I've figured out that one. So now I can piece these together, and I've got 40 cosine of 5x times the sine of 5x is my answer. So what I want you to see is that, you guys, we're just doing the chain rule once today for all these problems. Tomorrow and the next day, we're going to be looking at the chain rule for, where you end up doing it 2 times, 3 times, or maybe you're going to involve the product rule, the quotient rule with it. It's going to get a little bit more challenging. So your assignment is to follow up right here with this part of your assignment, okay? You do these problems on the back. The answer key is posted. Please use your work time wisely. Remember, during work time, where should we be? In our desks, and we should be quiet. I will find what I was going to show you.